This is the semester exam review for pre-calculus. We will get started. Number one gives me the points. A is -3, 2. B is -5, 4. And we're supposed to find the length of the segment, the distance. B is equal to x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Basically, the solution to the Pythagorean theorem is the derivation of that. So we get -5 minus -3 quantity squared plus 4 minus 2 quantity squared. And I made up everything here for this worksheet. I didn't take it out of a book or anything, so some of our answers might turn out a little conspicuous. -5 plus 3 is -2, squared is 4. 4 minus 2 is 2, squared is 4, and 4 plus 4 is 8. And then we need to simplify that radical. Okay, we're going to reach a point in next semester where we will not do that completely, but for now, I still want that to be 2 square root 2, not the square root of 8. Number 2, we're given the points -6, 3, and the point 2, 7. And we are supposed to find the slope. The slope, I take 7 minus 3. Well, the formula, if you want me to write that, I guess, is the y minus the other y over x minus the other x. That's what those subscripts allow me to do. So I get 7 minus 3 over 2 minus -6. So that's going to be 4 over 8, which is 1/2. Find the equation of the line through 0, -2. That's nice. They gave me the y-intercept. Perpendicular to 2x plus y equals 7. So that means that the slope of this line is -2. The slope of the line perpendicular to it would be positive 1/2. And so the equation of the line I'm trying to find is y equals 1/2 x, and then they gave me the y-intercept -2. And it doesn't say what it says up top, write the equations of the lines in slope-intercept form. So that's it. F of x is a linear function, and f minus 1 of 4, and f of 5 is 8. So what they've done is they've given us 2 points. This is the point -1, 4, and this is the point 5, 8. And what I want to do is find the slope. So that's going to be 8 minus 4 over 5 minus -1. And I get 4 over 6, which is 2/3. And I use that, y equals 2/3 x. I use one of the points. And again, it doesn't matter which one. I think this is going to come out nice anyway around it if I did my calculations correct, which I think I did. So I'm going to plug in 5, 8. So I get 8 equals 10/3 x plus b. I'm sorry, just 10/3. I substituted 2/3 in for x. Or 5 in for x, sorry. And then I'm going to subtract 10/3 from both sides. And 8 is 24/3. So 24/3 minus 10/3 is 14/3. And so my answer is y equals the slope 2/3 x plus the y-intercept, 14 thirds. Okay, number 5. A is 4, -1, and B is 8, 3, and we're supposed to find the midpoint. So midpoint, it's like find the average between the 2 points. We take 4 plus 8 and divide by 2. We take -1 plus 3 and divide by 2. And when I simplify that, I get 6, 1. So the midpoint is at 6, 1. Find the value of h, joining the points -2h and the point 4, 13, so that the line joining those points is parallel to the line 3x minus 2y equals 1. So if I solve this for y, I get 3/2 x. The slope here is 3/2. The slope of the line parallel to it is 3/2. So basically what I want to do is I want to take this line up here and take h minus 13 over -2 minus 4, set that equal to 3/2. And that'll allow me to solve for h, and that's what we're looking for. So let's see, 2h minus 26, that's -6 times 3 is -18. So I'm going to add 26 to both sides, and I get 2h equals 8, h is 4. Number 7, we have 4 plus 3i times the quantity 2 minus I. So we get 8 minus 4i plus 6i plus 2i minus 3i squared. So then that becomes plus 3 because I squared is -1. And 8 plus 3 is 11. And number 8, we have 5 plus I over 5 minus I. And to rationalize the denominator there, we multiply by the conjugate, top and bottom. So that's 5 plus I over 5 plus I. That works out kind of well in the numerator. I get 25 plus 10I plus I squared. In the denominator, I get 25 minus I squared. And so the numerator, that's going to be 25 minus 1, or 24. And down here, that's going to be 25 plus 1, or 26. And I can reduce that fraction. I can take a 2 out of everything. I can only do that if I can take it out of everything, not one or the other in the top. Okay? 9 is 7 plus 3i squared. And a lot of you like to distribute that 2 down in here, square this, and be done. And that's incorrect. This means 7 plus 3i times 7 plus 3i, which is 49 plus 21i plus 21i is plus 42i, and then plus 9i squared. And again, I squared is -1, so that's going to be 49 minus 9, which is 40. Remember too that these answers have to be written in the form A plus BI. That's just the definition of a complex number, and so we adhere to that. We still adhere to that. It's not one of those old math things that we've changed or gotten rid of. I to the 71st power, we find the closest multiple of 4, so that would be I to the 68th power times I to the 3rd, and I to the 68th is 1, I to the third is I squared times I, so that's minus I. Number 11, we have x to the fourth minus 15x squared. And I'm going to go ahead and move that 16 to the other side, get it set equal to 0. This is of the quadratic form, so it's going to be x squared minus 16 times x squared plus 1. And then x squared plus 16, or x squared minus 16, I can set that equal to 0. And then move 16 to the other side, take the square root of both sides, x is plus or minus 4. Same thing here, x squared plus 1 equals 0. So x squared equals negative 1. X is plus or minus I, because plus or minus I is the square root of negative 1. Number 12. Looks like I forgot to draw in that radical. 3n plus 10 equals n plus 1. So to solve that, I square both sides. 3n plus 10 equals n squared plus 2n plus 1. And set it equal to 0. N squared minus n minus, I don't like this, minus 9. All right. And that is not going to factor. I can guarantee the one on the test is going to factor. Because it doesn't factor, technically I have to use the quadratic formula. So I get negative 1 plus or minus the square root of 1 minus 4 times 1 times negative 9 all over 2. And so that's negative 1 plus or minus the square root of 37 over 2. And then I would have to do some extensive calculator work to figure out which one of those works, because only one of them is going to work probably, and it's probably going to be the plus one, because remember that when we square both sides or we multiply through by a variable, we produce an extraneous root, and we have to figure out which one of those is extraneous and get rid of it. And it's not always the case, but usually in these square root problems it is. So for what it's worth, we're going to leave that alone. And if we have questions on that in class before we take the test, we can go over that. Like before we take the test, as in before finals even start. Okay. 13 is 4a minus 7b equals 13, and 2a minus 7b equals 3. And this is a system of linear equations. We have two variables, so we need two equations to solve that. And so, yeah, I would just multiply this bottom one through by a negative 1. That's going to give me minus 2a plus 7b equals negative 3. I'm going to add that to that top equation. This is set up for the addition method. So that is what I'm going to do. And when I add those together, I get 2a equals 10. So a is 5. And I'm going to plug that in right here. So 2 times 5 is 10 minus 7b equals 3. Subtract 10 from both sides, and I get negative 7b equals negative 7. b is 1. We write our answer as an ordered pair, and they go alphabetically. So these two lines intersect at the point 5, 1. Number 14. X cubed minus 5x squared plus 2x plus 8 equals 0. So first of all, we list the factors of 8, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. We list the factors of the coefficient of x cubed. That's our highest degree term. And that's only plus or minus 1. So our possible rational roots are these numbers over this number, these numbers, whatever. And so basically these are our possible rational roots. So then we go to synthetic division. 3, 2, 1, 0, 2, 8. And we try to figure out which one of these is going to work. And I'm going to try 2. Oh my goodness, could it be? It is. When I get a remainder of 0, I know that I've found the root. So one of the roots is 2. Now to find the other 2, this is actually now a quadratic equation. And I can see that it factors. And so this gives me x equals 4, x equals negative 1, and I can't forget to put x equals 2. 15. Y equals 2x squared plus x minus 15. And we want to do all the stuff to that parabola. We want to find the intercepts. We want to find the equation of the axis of symmetry. We want to find the vertex. We want to find the domain and range. I'm going to make a change. Just looking at this, I'm going to make a change to this parabola. It's not going to turn out very nice because I'm going to get a fraction. And so I'm going to change this to, where to go? It was plus x. I'm going to change it to plus 4x. Okay. And so now, one problem with that is I'm not going to get nice x-intercepts, and that's okay. I'd rather sacrifice that. In fact, they may not even be. Anyway, that's neither here nor there. Graphing it is going to be a nightmare if I would have left that as 1. So I'm going to change it. So to find the vertex, we use the opposite of b over 2a. So that's going to be negative 4 over 4, which is negative 1. And then I plug in negative 1. And I get 2 minus 4 is negative 2, minus 15 is negative 17. Still not particularly nice, but so my vertex is negative 1, negative 17. And this parabola opens up. So that's going to be way down yonder. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So negative 1, negative 17 is down here. That's my vertex. Up a little bit. And then the y-intercept, well, the equation of the axis of symmetry is x equals negative 1. Remember, it has to be an equation. The y-intercept is 0, negative 15. Plug in 0 for x, that's what I get. And I can plot that point down here, 0, negative 15. That means I'm going to have another one of those over there on the other side of it at negative 2, negative 15. If I plug in 1, I get 2 plus 4 is 6, minus 15 is negative 9. So I could graph the point 1, -9, and again use my axis of symmetry to get the other point over there and getting a pretty good idea of what, my parabola looks like. Okay. As I said, the problem is going to be the x-intercepts, because that thing's not going to factor. And so I don't think it does anyway. I'm not going to spend time looking. I'm pretty sure it doesn't. So the opposite of b plus or minus b squared minus 4 times a times c all over 2a. Oh dear. 15 times 2 is 30, times 4 is 120, plus 16 is 136, and then 136 divided by 2 is 68, and that's 2 times 34, and that's 2 times 17. So that simplifies to 2 square root 34. This is wonderful. Over 4. I can reduce everything by 2. And there are your x-intercepts. Lovely. Domain, all real numbers. There's no restriction on x. There's not anything I can't plug in for x. And the range is greater than or equal to -17. That is all the stuff, okay, for that one. Then, let's see, number 16 says find the quotient remainder when x to the 4th minus 2x cubed plus 5x plus 2 is divided by x plus 1. And what we did there is we used synthetic division to do this. So 1, -2, 0, because my quadratic term is missing, and then 5, and then 2, and we're dividing by -1. So we pull down the first one, multiply, we add, we multiply, we add, we multiply, we add. Oh, wow. Wouldn't happen in a million years if I tried again. And so the quotient is x to the 3rd minus 3x squared plus 3x plus 2, and the remainder is 0. And because the remainder is 0, that means that x plus 1 is a factor of that quartic equation. That's lovely. 17. Let's get to the graph of y equals x cubed plus 5x squared plus 6x. That was relatively nice because we can take out the greatest common factor, which is x, and get x squared plus 5x plus 6, which I believe factors x plus 2, I put another parenthesis, x plus 2, x plus 3. So this is a cubic. My zeros are at -3, -2, and 0. It's positive out front, so I'm going to start down here in negative land and come up through here, down, a little bit bigger loop probably, and I hit that dot, of course, perfectly, and that's what it would look like. 18. Find the sum and product of the roots or find the sum product of the roots of the equation y 6x cubed minus 5x minus 2 equals 0. So the sum of the roots is the opposite of b over a, and b is the coefficient of the next highest degree term. If you look at this equation, there is no quadratic term. It's missing. So for this, the sum of the roots is 0. The product of the roots, because this is an odd degreed function, the product is the opposite of c over a. And so for this particular problem, the product of the roots would be the opposite of c, so that would be 2, and that's the constant, right? The opposite of the constant over a, which is the coefficient of the leading term, the highest degree term. And so we get 2 over a, which is 6, and that's 1/3. Okay. Number 19 gives us that 1 minus 2i is a root of the equation x cubed plus x plus 10 equals 0. And we're supposed to find the other two roots. Okay. Well, one of the other roots is 1 plus 2i. It's the complex conjugates theorem, that if 1 minus 2i is a root, then its conjugate is also a root. Okay. And then I'm going to use synthetic division to find the other root, the third root. And so 1, 0, 1, 10. And I listed these because those are the possible rational roots over the factors of the coefficient of the cube term there, which is 1. So it really is a moot point that it's over that. Anything over 1 is itself. So this is actually my list of positive roots. And I'm going to just go out on a limb and say it's -5. And I get 1, -5, -5, 25, 26, and I was deadly wrong. And so I'm going to try -2. I'm going to get 1, -2, -2, 4, 5, -10. Bingo, there it is. So if 1 minus 2i is a root, 1 plus 2i is a root, and then the rational root is -2. Okay? And last but not least, we have f of x equals the opposite of the quantity x plus 1, yeah, that's not what it says, x plus 2 squared minus 4. And the domain is x is greater than or equal to -2. So we are supposed to find the range, find the rule for f minus 1, graph them, find the domain and range of the inverse. I have to find the rule. I have to do basically everything that we talked about in class. I need to do everything except prove it. Okay, so that's nice. Proving it is the toughest part for when we have a quadratic, I think, especially when it's not in standard form. But anyway, the first thing I like to do is to graph it. So for my original function, I'm going to start at my endpoint of my domain, which is -2, and which is also, it's the vertex. The vertex is -2, -4. So if I plug -2 in, I get -4. And then I'm supposed to be getting bigger, so plug in -1, I get -1 plus 2 is 1, squared is 1, I get -1 minus 4 is -5. Plug in 0, I get -4 minus 4 is -8. Plug in 1, I get -9, because 1 plus 2 is 3, squared is 9, so -9 minus 4 is -13. I probably won't graph that one. And then for the inverse, that will be -4, -2, -5, -1, -8, 0. Okay, so let's see if we can put that together over here. That's a terrible line. Terrible quadratic system, period. Coordinate system, period. 1, 2, 3, 4, 5, 6, 7, 8, I think is what we're going to need. 1, 2, 3, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8. Okay. So the original -2, -4, right here. -1, -5, right here, and 0, -8, right here. So this is that side of that parabola. Hold it, miss my point there. And then the inverse, -4, -2, -5, -1, and -8, 0. So it is that. Okay, so this is f of x. This is f minus 1 of x. Okay. The domain of f is given. It's x is greater than or equal to -2. The range of f is obviously right here. I'm at -4, but it's going down. So my range for f is y is less than or equal to -4, which means for my inverse, this is for f of x, okay, which means that for my inverse, f minus 1 of x, I don't even need to look at the graph. The domain is, I change that y to an x, so I get x is less than or equal to -4. In my range, I change that x to a y. Y is greater than or equal to -2. And that's my domain and range. The only thing left to find is the rule for the inverse. And that's where I change from function notation to this notation, y equals. Then I interchange x and y. So x equals minus the quantity y plus 2 squared minus 4. And then I go about solving that thing for y. And so the first thing I'm going to do is get rid of that 4. And I'm not going to take the square root of both sides with this negative being in front of here. So I'm going to get rid of that negative, which means this is going to be minus x minus 4 equals y plus 2 quantity squared. Now I'm going to take the square root of both sides. So plus or minus the square root of minus x minus 4 equals y plus 2. And then I'm going to subtract that 2 and get -2 plus or minus the square root of minus x minus 4. And then I have to determine, which one is it that I want. And we go by our common sense, and I look back at my graph. This is the right side of my parabola. Okay, this is the right side of my parabola. This is the top side of what would be this parabola. The rest of this parabola would look like this. The rest of this parabola would go down like this. So right side, top side tells me that f minus 1 of x is negative 2 plus the square root of minus x minus 4. So that is the rule for the inverse. We also talked about plugging in a point and determining which one is correct. So if I plug in negative 2 plus or minus this point, negative 5, negative 1, so it would be the opposite of negative 5 minus 4, and I need that to equal negative 1. So that's going to be negative 2 plus or minus 5 minus 4, and 5 minus 4 is 1, and the square root of that is 1. And which one is going to give me negative 1, and it's when I add. If I subtract, I'm going to get negative 3. That's not the point I'm looking for. When I add, I'm going to get negative 1. That's the point I'm looking for. So that further verifies, confirms, says, whatever you want to call it, that it should be the plus 1 that I'm writing as my inverse, not the negative 1. So my inverse is negative 2 plus the square root of minus x minus 4. And there's my domain and range for each, and there's my graph and my rule, and that's everything we were supposed to find. Okay, and that is it, I believe. That's all I'm showing on my review sheet, so looks like we're done there. Good deal.